Good morning, students. Students, in our previous lecture, we discussed with you something about the distorted geometry or irregular geometry. And I told you, if in a molecule, both the bond pair as well as a lone pair of electron is present, then the molecule will have a distorted geometry. Now, the entire list of that was given to you. I hope you must have studied that. Now, you must note one thing, student. There are more than lakhs of inorganic compounds. If you begin to learn the shape of every molecule, it will take the chemistry out of the control. So what we need to do is, we need to find out the way to study the geometry and the hybridization of a molecule. So in today's lecture, we will be studying a formula which will help us in predicting the geometry or the shape of the molecule. So prediction of the geometry or the shape of the molecule. Prediction of geometry. Geometry means the shape of the molecule. Prediction of geometry or the shape of molecule. Now, to predict the geometry or the shape of the molecule, we must know what type of a hybridization is present in the molecule. And to find out the hybridization, we have a formula H will be equal to half into V plus X minus C plus A. So hybridization will be equal to half into V plus X minus C plus A, where V is the number of electrons in the valence shell of the central atom. This is the number of electrons in valence shell of central atom. In the valence shell of the central atom. X will be the number of monovalent atoms. Number of monovalent atoms. C will be the charge on the cation and A will be the charge on the anion. The C is the charge on cation and A will be the charge on the anion. This A over here will be the charge on anion. Am I clear? The charge on the cation and the charge on the anion. So how do you find out the hybridization of the molecule? Half will be equal, H will be equal to half into V plus X minus C plus A. Student, I have already told you, if the value of H comes to be 2, the type of hybridization will be SP. How? The value of H and the type of hybridization. We know the value of H and then what will be the type of hybridization? Value of H and type of hybridization in the molecule. Just check out. If the value of H is 2, the type of hybridization will be sp. If it is 3, the type of hybridization will be sp2. If it is 4, the type of hybridization will be sp3. If it is 5, the type of hybridization will be sp3d. Then, if it is 6, the type of hybridization will be sp3d2. And if the value of hybridization comes to be 7, the type of hybridization comes to be sp3d2. Am I clear, student? So, we will find out the value of H and from this value of H, we will be able to find out what type of a hybridization will be present in the molecule. Is it clear or not? Now, if the hybridization was S, then the geometry or the shape of the molecule We also discussed with you the geometry and the shape of the molecule. What was the geometry and the shape of the molecule? Just we are trying to recollect what we discussed always. So geometry or the shape of molecule. Geometry or the shape of the molecule. If it is sp, the shape of the molecule will be linear. sp2, it is trigonal planar. If it is sp3, the geometry of the molecule will be tetrahedral. We discussed this. sp3d, it is trigonal bipyramidal. Trigonal bipyramidal. Remember, sp3d2 octahedral, and this is a pentagonal bipyramidal. Pentagonal bipyramidal. I hope you remember this instrument. Now, in the case of sp hybridization, the geometry was only linear. But in the case of sp2 hybridization, I told you it can be trigonal planar. If it contains the lone pair, then it will acquire the V shape. In the case of sp3 hybridization, when there was present a one lone pair, so this was a trigonal pyramidal, and V shape, as was in the case of water molecule. In the case of sp3 dehybridization, there were three distorted geometry. These were the seesaw, T-shape and the linear shape. This was seesaw. Remember student, if it was having one lone pair, then T-shape and the linear geometry. T-shape, it was having a two lone pair, and then the linear geometry. In the case of octahedral geometry, if there were present a lone pair of electrons, there were two geometry. This was square pyramidal and square planar. In the case of octahedral geometry, this was square pyramidal. When it was having one lone pair, when it was having a two lone pair, it was having a square planar. Tell me whether we are able to recollect this or not. Fine. And pentagonal bipyramidal in our syllabus we have a regular geometry. Now one more thing. These were the geometries which were obtained when the molecule was having a lone pair of electrons. Here again, one lone pair, two lone pair, three lone pair. Here, one lone pair and a two lone pair. The question is how to determine the lone pair of electrons. So student, always remember, number of lone pair L will be equal to H minus M minus D. H minus M minus D. Remember this formula. How to find out the number of lone pair? It will be equal to H minus M minus D. This is the number of lone pairs. H was hybridization. The value of hybridization can be this. Hybridization. M is monovalent atom. Monovalent atoms. And D over here will be a divalent atom. Am I clear? Suppose we have to find out the geometry of ClF3. Then how do you find out the geometry of ClF3? First of all, we will find out the value of H. H will be equal to half into V plus X minus C plus A. Which is the central atom over here, chlorine. So this will be half into number of monovalent. This will be chlorine. How many monovalent atoms? 3. Charge on the cation 0, charge on the cation 0. So here, number of electron in the valence shell will be 7. If you solve it out, the value will come out to be equal to 5. Now, if the value of H comes to be 5, it will be having what type of hybridization? sp3d. Now, find out the lone pair of electron over here. lone pair will be equal to H minus N minus P. How many? What is the value of H? 5. How many monovalent atom? 3. Divalent atom? 0. So how many lone pair are coming? 2. Fine. How many lone pair are coming? 2 over here. So this over here, when I say 5, it is a type of AB5 molecule. When it contains 2 lone pair, so molecule becomes the type of AB3 and 2. Mean to say 3 bond pair and the 2 lone pair of electron. When there are 3 bond pair and 2 lone pair, what was the shape of the molecule? T shape. 4 bond pair, 1 lone pair, seesaw. 2 lone pair, T shape. 3 lone pair, D geometry. So what will be the shape of the molecule? It will be having a T-shaped structure. Then how do we make the T-shaped structure? It is trigonal bipyramidal. First of all, the geometry will be of this kind. This is trigonal bipyramidal geometry. This is a chlorine molecule. Fine. Now, it will be having a T shape. Just see, this will be a T shape. So this will be fluorine, this will be fluorine, and this will be fluorine. 2 of the lone pair of electrons is to be put over here. 1 here and 1 here. This is what geometry? This is a T-shaped molecule of a ClF3 molecule. Am I clear? So this is what shape? It will be T-shape. So student, by using this concept of hybridization, we may easily determine the hybridization and the geometry in the molecule. Now look over here. If you want to find out the geometry of methane molecule, CH4, what will be the formula? H will be equal to half into. How many electrons in the valence shell of carbon? 4. 4. Half into V plus X. Number of monovalent atom? 4. Charge 0. Charge on the line 0. So this will be 4. So if the value of H comes to be 4, what type of hybridization it will be? It will be sp3 type of a hybridization. How many lone pair will be present over here? It will be H minus M minus P. This will be equal to 4. How many monovalent atom? 4. Divalent atom? 0. So number of lone pair will be 0. So this is what type of a molecule? It is AB4. It means it is having no lone pair. When it is having no lone pair, it will be having a regular tetrahedral geometry. So how will we make the methane molecule? This will be carbon, this will be hydrogen, this will be hydrogen, this will be hydrogen, and this will be hydrogen. So this over here will be the geometry of a methane molecule. I think I shall be very, very clear over here. Is it clear? So this is how you have to find out the geometry of the molecule or the shape of the molecule using the concept of a hybridization. Is there any problem, student, with this? Now, just see over here. If I take another example, to determine the hybridization in this case over here, and we take the molecule of xenon oxyfluoride, XeOF2. Now see, in the normal circumstances, we are not in the position to find out the geometry of this kind of a molecule. But we will apply the formula. H will be equal to half. Xenon is the central atom. How many electrons in the valence shell? 8. Plus number of monovalent atom. Which is the monovalent atom over here? Fluorine. 2. Charge on the cation? 0. Charge on the anion? 0. So value comes to be equal to 5. If it is 5, what type of hybridization it will be? It will be sp3d type of a hybridization. So geometry of the molecule will be sp3. Am I clear? How do you find out the lone pair? It will be equal to H minus M minus P. What is the value of hybridization? It is 5. How many monovalent atom? 2. How many divalent atom? 1. So how many lone pair are present? 2. Fluorine valency is 1. So how many monovalent atom? 2. Oxygen valency is 2. So how many divalent atom? 1. So what is the value coming? 2. So molecule will be of the kind AB3 Here again in AB3L2, what will be the shape of the molecule? T shape. It is having a 3 bond pair and a 2 lone pair. So shape of the molecule will be a T shape. Yes? So how do we make a shape? This will be xenon. We have xenon oxyfluoride. So how do we make this one? Suppose this is oxygen. This over here will be fluorine and this will be fluorine. Now, this will be a shape. At the two of the equatorial position, we will be having a lone pair of electrons. Here again, we will be having a lone pair of electrons. So this will be a shape of xenon oxyfluoride, which appears to be a T-shaped molecule. Tell me whether I am getting it clear for you or not. Now, if the molecule is HCF4, how do you find out the hybridization? It will be equal to half into 8 plus 4. Am I clear? Minus 0 plus 0. So what is the value coming? 6. If the value of X is 6, what type of hybridization? sp3d2. So it will be having sp3d2 type of hybridization. If you find out lone pair, what is the hybridization coming? 6. Minus 4. How many divalent atoms? 0. So this will be 2. The shape of the molecule will be of what kind? 4 bond pair and 2 lone pair. So it is the molecule of the type AB4 and 2. With hybridization 6, molecule will have what geometry? Octahedral. But it is having a 2 lone pair. So with the 2 lone pair, it will acquire what geometry? Square planar. So how will we make this? I told you that in the octahedral geometry, 2 of the lone pair must be kept in the diagonal position to each other. So how will we make this structure? This will be xenon. This is fluorine, fluorine, and this is fluorine and fluorine. On any of the 2 diagonal position, you may put up the lone pair. And this shape of the molecule will be called as a square planar shape. This will be called as a square planar. Am I clear, student? So you must have been able to understand how do we determine the geometry of the molecule. We may determine the regular as well as the irregular geometry of the molecule. The concept will be, formula will be H will be equal to half into V plus X minus 3 plus A, and the lone pair will be equal to H minus M minus T. I think the concept of hybridization must have been very clear to you, student. We have done with you to find out the geometry of the molecule. Now, student, just see. Here the formation of a molecule has taken place. Now what we need to learn is how the distribution of electron will take place in the molecule. That will be discussed with you in the terms of a theory which is called the molecular orbital theory. So in our next lecture, we will start distributing the electrons into the molecule. By now we have learned with the modern concept and with the concept of a hybridization how the formation of a covalent bond takes place. So we will meet again in the next lecture. Till then, thank you.